In this video, we're asked to verify a general solution of a second-order differential equation. And the proposed general solution here is this one. It's a linear combination of sine of ix and cosine of ix, where I is the imaginary unit. In other words, I is the square root of -1. In other words, if I square I get -1. And this is supposed to be a solution of this differential equation, f double prime equals f. In other words, if I differentiate this function twice, I should get back to the original function. So the way you verify the solution is by just starting to take derivatives. And when I differentiate the first term in f, I have to differentiate the sine function with respect to its argument, so I end up with a c1 cosine of ix. But then the chain rule says I have to differentiate that argument with respect to x, and that produces an I out in front. A similar thing happens in the second term. It's just that the derivative of the cosine function gives me a minus sign. So I end up with a negative. And again, the chain rule is going to produce a factor of I when I differentiate the argument of this cosine function. The c2 is a spectator here. And then the derivative of cosine, of course, produces that sine function with the minus sign out in front. Then I take the second derivative. And in the first term, I'm going to get a minus sign from differentiating the cosine function with respect to its argument. I'm going to get another factor of I because of the chain rule taking the derivative of the argument of the cosine function. And I get a sine of ix. In the second term, again, I get another factor of I because of the chain rule. So now I have an I squared and a c2 and a cosine of ix. And then I realize that I squared is just -1 because I is the imaginary unit. So I end up with -1 or a +1 times c1 sine ix. And the same thing happens in the second term. I end up with a positive c2 cosine ix. And then I realize I'm just looking at my original function f of x. So that concludes the proof that f double prime of x is equal to f of x. So we've shown that this function f of x is a solution of the second order differential equation. Along with the fact that I have two arbitrary constants in this, that shows this is a general solution of the second order differential equation, because the general solution of a second order equation must have two arbitrary constants. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.